Bismillahirrahmanirrahim. Assalamu alaikum. This is Faryal Javed, roll number 21 T07 from Telecommunication Engineering Department UT Texila. So today I'm going to solve lab manual 7 of digital signal processing, that is frequency analysis of digital sequences. So the lab objective of today's lab is study digital sequence in term of frequency spectrum, the contribution of high frequencies in a sequence, and then the contribution of low frequencies in a sequence. Moving toward task 1 of today's lab, that is consider the following sequence. Plot the signal in MATLAB. If the sampling frequency is 20k samplers per second, then redraw the sequence after removing frequencies above 5k Hz, and then redraw the sequence after removing frequencies above 7 kHz. Observe and discuss the effect of this removal of frequencies. So the output to the first task is as shown. So basically we have defined the signal, the input signal x, and then we'll define the sampling frequency f of s. The original signal x is plotted against the time to visualize its amplitude variation over time, and then then we applied the low pass filter using the function of FIR1 function with a specified cutoff frequency and order. The design filter is applied to original signal using the filter function to obtain the filtered signal, and then we plot the filtered signal. The filtered signal is plotted against the time to visualize the effect of low pass filtering. This plot shows the amplitude variation of the filtered signal with the high frequencies component filtered out, and then we repeat the same process for the different cutoff frequencies. Here is the output to the signal with frequencies less than 5 kilohertz, and then the signal with frequencies less than 7 kilohertz. Moving toward task 2 of today's lab, that is use the following audio signal, calculate DFT, remove the upper half of frequencies and then remove the lower half of frequencies, and observe a change by listening the audio. The output to this task is will be shown. So in this task we basically read the audio file, that is with a name of audio file dot wave dot AAC, and then this store this audio data in the Y, and then the sampling frequency is f of s. Playing the audio stored in Y using the sampling frequency f of x, and then calculate the discrete Fourier transform, and then the removing the upper half frequencies, find the index corresponding to one fourth of length of audio signal, and set all DFT coefficient beyond that index to a zero. And then listening to the filtered audio, that is upper half, if we remove the save the filtered audio to a file and then play it separately. Then removing the lower half of frequencies, set all the DFT coefficients up to the index corresponding to one fourth of the length of audio signal to a zero, effectively removing the lower half of frequencies. So we'll wait for the code to run. And here is the output to DFT of audio sequences without a removal of lower frequencies and the upper frequencies. And then we'll move towards our task 2, that is after removal of lower frequencies, the output looks like this, that is DFT of filtered audio signal. And then we'll have the last task of today, and that is to remove the upper half of frequencies. These steps basically allow us to observe the effect of removing the upper and lower half of frequencies on the audio signal visually through the DFT of magnitude spectrum, and audibly by listening to a filtered audio. And here is the output. So this is it for today's lab. Thank you so much. Allah Hafiz.